4, 6, it's a sequence. And anything that has a pattern is going to be a sequence, okay? So there's different kinds of sequences: arithmetic sequence, geometric sequence we're going to talk about. And later in BC Calculus, you're going to have different other types of sequences. So having said that, let's start with the basic sequence. Let's say the arithmetic sequence where you have to add a particular number to get to the next number. Let's say we're adding 5 each time. 5, 10, 15, 20, so on and so forth. Or we can also subtract, so we can go 5, 0, minus 5, minus 10, so on and so forth. This is known as an arithmetic sequence because I'm adding and subtracting a particular difference. Now the problem is, how do I find, if that's my first term, second term, third term, fourth term, how do I find my, let's say, 100th term? Well, I don't want to keep doing that, so I have to come up with some kind of a formula. So here's the formula, okay, for arithmetic sequence. So we call a sub 1 the first term, and a sub 2 is really the first term plus some difference we'll call d. And of course a sub 3 is nothing more than a sub 2 plus a difference. That means that we're going to add one more difference each time, but a sub 2 is nothing more than that, so I'm going to substitute that in, and when I do the substitution, I'm going to get a sub 1 plus d, which is going to give me a sub 1 plus 2d. And then of course I'm going to do the same thing the next term, a sub 4, and that's going to be a sub 3 plus d, but a sub 3 is nothing more than that, so I'm going to replace that with a sub 1 plus 2d, and then plus another d at the end, which is going to give me a sub 1 plus 3d. So notice there's a pattern here. On the fourth term, I'm adding 3 differences. So my a sub 5 will be a sub 1 plus 4d. So on and so forth. So if I want to find a sub n, that means any term, the nth term, it will be a sub 1 plus n minus 1d. And using that formula, I can find any term that I want. So let's go to the problem that we had before. Let's say we have a 2, 4, 6, 8, so on and so forth. This is an arithmetic sequence because I'm adding 2 each time. So if I want to find, let's say, a sub 10, so the 10th term of this sequence, so I know what my a sub 1 is, which is 2, plus 10 minus 1, which is the n is 10, so 10 minus 1 times the difference, which is 2. So that's going to be 2 plus 9 times 2, okay, and that turns out to be 2 plus 18, and that turns out to be 20. So the 10th term of this sequence right here is going to be 20. Of course, it doesn't have to be 10, you could be 1000, and you can do that. You can still find that using that particular formula. Alright, now we're going to talk about arithmetic series. Okay, what is an arithmetic series? The only difference in a sequence series is an addition. So if you had 2 plus 4 plus 6 plus 8 plus dot 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 dot, that is known as a series. Okay, how do you find a sum of, let's say, I want to find, we'll use S for sum of, let's say, 100 terms. Again, you want to come up with the formula to be able to add arithmetic series. So here's the formula for that. Okay, let's suppose we know the first one. Okay, let's just call S as a sum. So we know we're going to add first term plus second term plus third term plus dot 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 nth term. Okay, so instead of writing that a sub 1, a sub 2, we came up with the formula for each one of these. A sub 1, and then a sub 2 is really a sub 1 plus a difference, and then a sub 3 was really a sub 1 plus 2 differences, and then plus dot 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 dot. Okay, and then a sub 1 n, it was really a sub 1 plus n minus 1 differences, minus 1 difference. Okay, but let's suppose we rewrite this. Okay, this is my last term. Let's suppose we rewrite this backwards. Okay, and then when I do that, this is going to be the first term now, a sub 1 plus n minus 1 difference, and then the one before that in the dot 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 will be, okay, a sub 1 plus n minus 2 difference, okay, and then plus dot 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 dot, the last one is going to be a sub 1. Now, if we subtract, okay, if you add these two columns, okay, look what happens. Okay, let's add them together. So s plus s is going to give me 2s. Now, this is the first term here, and that's the first term there. So I'm going to have 2a sub 1s plus n minus 1 difference. So that would be 2a sub 1 plus n minus 1 difference. And then when I add this term and this term, okay, when I line them up and add them, I'm going to have again 2a sub 1s, and then d 1 difference plus n minus 2 difference, which actually ends up being n minus 1 difference, and so on and so forth. Okay, when I add the last two, I'm going to get exactly the same thing, which is 2a sub 1 plus n minus 1 difference. Well, how many of these do I have? Well, altogether I have n terms, so I can rewrite this as n times 2a sub 1 plus n minus 1 difference. When I divide by 2, my s will become n over 2, all that term, times 2 times a sub 1 plus n minus 1 difference. There's my formula. Finding sum of an arithmetic series. Now, of course, inside here, I can break this up as a sub 1 plus a sub 1 plus n minus 1 difference. Okay, because I can just split up the two a sub 1s. Well, this is really a sub n. Okay, that's what we found. So we can actually rewrite this formula as n over 2, all that times 2 times a, oops, not 2. Okay, let me backtrack that. Okay, n over 2, all that times a sub 1, which is the first term, plus a sub n, which is the last term. Okay, so both of these formulas work. Okay, it all depends on what information you're given. If you're given the first term and the last term, and you're not given the difference, then you can use this second formula. But if you're not given the last term, just the first term and the difference, then you can use the first formula. Alright, so let me rewrite these two formulas again for you. So my sum is equal to n over 2, all that times 2 times a sub 1 plus n minus 1 difference. Okay, and that also could be written as n over 2, all that times a sub 1 plus a sub n. So, how can we use this? Let's say we have a 2 plus 4 plus 6 plus dot 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 dot. Let's say we want to add the first 100 terms. Okay, you can use either one of these formulas. You can either find the 100th last term, okay, and then use this formula, or you can, since we don't know the last term, it's probably easier to use that formula, which is going to be n is 100 over 2, all that times 2 times the first term, which is 2, and that's my 2, okay, and then I have a plus 100 minus 1 times difference. Okay, that's really 50 times 4, and my difference, I know my difference, so I might as well put that in right now. So let's go ahead and put the difference in, and difference is 2, so let's put that in. So I'm going to get 4 plus, this is 99 times 2. Okay, if we keep going, that's going to be 50, all that times 4 plus, that's 18, 198, okay, and then that will be 50, all that times 202, okay, so when you multiply this out, you're going to get 10, 10, and 0, okay, So there it is. That's the sum of first 100 terms. Okay, now sometimes they give you the last term, so they won't tell you how many terms you have. Okay, you have to go find that. Alright, now let's clear that. Let's go to geometric sequence. Geometric sequence occurs when you have to multiply by a number, which is what we call a ratio. So let's say we have a 2, 4, 8, 16, 32, so on and so forth. So I'm multiplying each time by 2, so I call that my ratio. Okay, whenever you have a ratio, again, you have to multiply. It could be positive or negative number, and it could be a fraction. It doesn't matter. Okay, this is known as a geometric sequence. So how do you find, let's say, a sub 100, the 100th term? You don't want to keep multiplying. So we want to come up with the formula. And here's the formula. Okay, a sub 1 is equal to the first term. Okay, that's my first. Okay, and my a sub 2 is really the first term times some ratio we'll call r. And a sub 3 is really a sub 2 times r. But a sub 2 is really that right there. So that's going to give me a sub 1 times r, which is going to give you a sub 1 times r to the second. Okay, there's going to be a pattern here. Okay, a sub 4 is going to be a sub 1, okay, times the power will always be 1 less on the r, so r to the third. So on and so forth. If you go all the way down, a sub n will be a sub 1 times r to the n minus 1 power. And that's my formula for a geometric sequence. So if I have a 2, 4, 6, oh, not 6, 8, because I'm multiplying by 2. So if I have 2, 4, 8, 16, so on and so forth, if I want to find the 100th term, I'm just going to plug into the formula, 2 times my ratio. How do I find ratio if I didn't know that? Take any number, divide by the previous number. So 4 divided by 2 is 2. 8 divided by 4 is 2. Okay, 16 divided by 8 is 2. So you can always find the ratio. So my ratio is 2. Okay, and then my n is 100 minus 1. So my answer is 2 times 2 to the 99. Okay, which is really 2 to the 100. And that is, that's a big number. Okay, so we're going to leave it like that. Alright, that's a geometric sequence. Now obviously when we add things, we're going to call that series. So when you have a 2 plus 4 plus 8 plus 16 plus dot 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 dot, that's known as a geometric series. Okay, and let's say we want to add the first 100 terms, s sub 100. Well, you like to have a formula rather than listing each one and adding them. So here's the formula for a geometric series. Okay, geometric series, let's call the first one is a sub 1 plus s sum is equal to a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus the last term a sub n. Of course, if we were to rewrite this, I can rewrite this as a sub 1 plus a sub 1 r plus a sub 1 r squared plus dot 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 plus a sub 1 r to the n minus 1. Okay, so each term can be expressed as that. So this is same as this, same as that, same as that, and that's same as that. Okay, so what I'm going to do is I'm going to multiply everything by negative r. So when I multiply this side by negative r, I'm going to multiply this by negative r also. So negative a sub 1 r, multiply this by negative r, it's going to be negative a sub 1 r squared, and then multiply that by negative r, which is going to be negative a sub 1 r cubed. Okay, and then dot 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 dot, and then the last one is going to be a sub 1 r to the n. Okay, so now what we're going to do, if you notice, when we add these, okay, the left hand side, I'm going to have s minus r times s, right hand side, that term and that term are exactly opposite, so they're going to cancel. And then this term and this term are going to cancel. Okay, every term is going to cancel out. Okay, and this term is going to cancel out with the one before that. So the only thing that's left is the first term on the top, which is a sub 1, and then the last term on the bottom, which is minus a sub 1 r to the n. Okay, we're going to factor out an s from the left side, which is going to give me s times 1 minus r. On the right side, I'm going to factor out a sub 1, which is going to be 1 minus r to the n. And then when I divide by 1 minus r, my sum is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. And that is the formula for sum of a geometric series. Okay, so if you want to find, going back to the other problem, let's say you have a 2 plus 4 plus 8 plus 16 plus dot 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 dot, and if you want to find the first 100 terms, you can use this formula. My first term, which is my a sub 1, okay, is going to be 2, all that times 1 minus r. Ratio is any number divided by the previous one, which is 2 to the nth power. In this situation is going to be 100th power, and all that's going to be over 1 minus r, which r happens to be 2. Okay, and when you simplify this, you can get the answer. As you can see, simplifying 2 to the 100th power is going to give you a large number. So we're going to leave it like that for right now. Okay. Alright, the other thing you have left in this section is known as infinite geometric series. So let me clear this one. Have sum is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. Now, what happens is infinite geometric series is related to geometric series. Let's say I have a 1 plus 1 half plus 1 fourth plus 1 eighth, so on and so forth. I'm multiplying each time by a number that is less than 1. Now it could be negative, but as long as it's less than 1, okay, it's going to get smaller and smaller and smaller. So if the absolute value of r is less than 1, which means it's between 1, okay, and negative 1, if it's like that, because that means the same thing as that, okay, then you can add up infinite number of terms and come up with a finite solution. Why? Because of this reason. If this happens to be a fraction, which is less than 1, when you raise, let's take an example, that's like 1 half. Okay, when you raise that to like a 1,000th power, this is going to get really, really close to 0. Okay, so that means this is going to disappear altogether. So my formula for infinite geometric series will look like this: a sub 1 all that over 1 minus r, because this turns into 0 and 1 minus 0 is 1, so this is the infinite geometric series. So here's an example of infinite geometric series where my first term is 1 and my ratio is 1 half, because I'm multiplying each time by 1 half to get the next term. I can add all these up. So if I want to add up infinite number of these terms, my first term is going to be 1, and it's going to be 1 minus 1 half is my ratio. So when I plug it in, I'm going to get 1 over 1 half, and when I simplify that, that turns into 2. Actually, if you keep going out on this series forever and ever and ever, it's going to get closer and closer to 2. So we say sum of that is 2. Okay. Now, sometimes you can write this. You don't have to. Write this as expanded version of it. So we can write this as summation notation. And let me show you how to do that real quickly here. Let's say you have 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus dot 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 dot. My ratio is equal to 1 half. Okay, my a sub 1 is equal to 1. So I can write this as sum. Okay, n is going from 1 to infinity. Okay, my first term is 1 times the ratio, which is 1 over 2, okay, to the nth power. Okay, what that really means is I'm going to start out by I'm going to start out with a 0. Excuse me. 0 to infinity. I'm going to start out by putting a 0 for the n. When I put in a 0 for the n, this turns into 1. Okay, so 1 plus. The next number I'm going to put in for n is, instead of 0, I'm going to put in 1. So 1/2 times 1 is going to be 1/2. Next I'm going to put in for n is 2. Okay, and that plus, okay, 1/2 raised to the second power is 1/4. 1/4 times 1 is going to be 1/4. And the next number I'm going to put in is 3. Okay, 1/2 raised to the third is going to be 1/8 times 1 was 1/8. Looks like I'm getting the same thing. So you can write it like this, okay, using, okay, n is going from some number. We can start at 1 or 0, it doesn't matter, okay, to some number, we call that k, and a sub 1 r to the n. Okay, and that's our little formula. It just means to expand. Okay, arithmetic sequence. Okay, a sub n is going to be a sub 1 plus n minus 1 difference. Arithmetic series. S sub n is equal to n over 2, all that times 2 times a sub 1 plus n minus 1 difference. Or okay, n over 2, all that times a sub 1 plus a sub n. Okay, geometric. Okay, this is arithmetic sequence. This is arithmetic series. Okay, this is a geometric sequence. Okay, that is going to be a sub n is equal to a sub 1 r to the n minus 1. Okay, and then geometric series. Okay, so that is s sub n is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. Okay, and then the infinite geometric series. Okay, infinite geometric series is s sub infinity is equal to a sub 1 over 1 minus r. And that's such that absolute value of r has to be less than 1. This condition has to be true.